Okay, so what was this year about? This year was about this. This was about Delta and the Omicron. Okay, we started out with Delta and we ended up with Omicron. And if you look at it, they look very much the same, I would say. Okay, so I don't know. These kinds of matters, I consider myself a total ignoramus. Okay, so I'm not going to boast or anything, but just objectively by looking at this, I would say they're very much the same. In fact, someone came in and asked the following, or said the following. He said that the Omicron is the common cold. Okay, and when I looked at when I looked at the viruses, they do look the same. Look, if you look at the flu virus, it looks very much like the Omicron virus. Can someone tell me what the difference is? At least from a structural standpoint, they look exactly the same or very much the same. Now, maybe internally, that's what I'm assuming, the molecules are structured differently, and so they have different properties. Okay, that's all I can think of. Otherwise, I would say that, what we got in front of us is just a common virus. Okay, and again, I'm ignorant in the matter, so I'm not going to put my hand in the fire for you. I'm just saying that objectively, they look the same. Hopefully, someone out there knows a little more and can tell you exactly what is different about those two viruses. Now, there is a possibility. I want you to think about this. The United States accuses China of creating this thing in the lab in Wuhan. And the Wuhanians, they're accusing the United States of bringing the stuff over. There was a meeting of military people, a get-together, worldwide get-together, military people in 2019. I think it was August of 2019 in Wuhan. And the Chinese are saying that the Americans brought that and threw it in there, after preparing it in their intelligence lab. And the Americans say the opposite. It's the Chinese who created it in the lab and spread it from Wuhan. Okay, these are mafias that they just point their fingers at each other. It doesn't concern me because we're never going to find out who's right. It's just going to be finger pointing, right? But the issue here is that if this is just a common cold, I can imagine a lab just modifying something in there on the virus of a common cold, for those of you who believe in viruses and that they do damage, et cetera, et cetera, et cetera. Well, if they can modify the virus just a little bit and turn it into this, COVID thingy, well, yeah, then it has different properties and et cetera, et cetera. So I can believe that that could have been a something manufactured in the lab. But now keep in mind the following. Wuhan is a city of 11 million people. Okay, if you look at the entire metropolitan area, it's 19 million people. They never had COVID over there. They just found this out, in 2020? What was it, 2020? I think it was the start of this thing. I mean, is this just when this came up? No one ever caught this thing? In all these hundreds of years, Wuhan has been around for centuries. No one ever caught this thing. Could it be a last-minute mutation out there in the chicken coop? Chicken has the common cold and turns it into the COVID virus. I don't know, but it's something you should think about. Anyways, I'd rather think of not this past year, which was pretty good for me. I want you to remember that, I've been online for now 13 years, going on 14 years, and I think I did pretty good. Why? You say, Bill, you don't have too many followers. Hopefully I don't have any followers. I think it's creepy. I don't want anyone following me. No, but the fact that some people have understood the theory, and a lot of them like the theory, and that was my only goal, really. Remember, when you're fighting the establishment, it's very, very impossibly hard to get your theory across. So when you look at it from that point of view, I've had quite a bit of success, okay? And my success is not how many people I recruit there. I said, if I can, show one person and that person understands and likes the theory, I'm okay. And I've had a few of them, and so, it's up for you to take it to wherever you want to take it, it's up to you. And yeah, I've had also detractors, a lot of people who attack me, and that's fine. That's their job, okay? But anyways, I'd like to think of the coming year as the year in which the rope comes across to more people, and I'll call it the year of the rope, 2022. Okay, and some people might say, what is this rope thinking about? Especially those people who are not familiar with what's going on in this channel. Okay, And so I have to go with a lot of stuff that we did this year, but you know, I got to condense 365 days into a few minutes. Okay, and so let's start here. Okay, what we've got is not only a new version of light and gravity, we have a new language. Okay, we've defined critical words that we believe are necessary to provide physical interpretations in physics. We've redefined physics because we say that physics is not about running experiments or measuring, doing equations. Physics is about physical interpretations exclusively. Okay, people want to know how the universe works. Wants to know how gravity works. Want to know how electricity works. How magnetism works. How light works. And in order to do that, I say you need a mediator. You need an object. You need a thing that mediates that transaction. Okay, so that's the bottom line. And so not only have we defined physics, we went one further step and said we are redefining what science is. Okay, and science is not, again, about doing measurements and running experiments and putting out equations or whatever. Science is a little more than that, or better said, it's parallel to that. None of that has anything to do with science. Okay, so I'm not saying you got to agree with it. I don't say that you have to believe in it. I'm just saying that's what we say is science in this channel. Okay, so we have a different version of what science is, what physics is, what light, gravity, etc. is. Okay, and you don't have to agree. We're not asking you to agree. We're asking you to understand. Okay, and so this is how we break up science. Okay, here it is. Okay, we say that science is what? Rational explanations. Okay, that's what we say that science is about. And it's divided in two branches, only two, and not into 10 different branches, but only two. And from these two, these are the two major headings from those spring all the other subcategories. Okay, and we have, on one hand, we have physics, and the other one, we have philosophy. Okay, what is physics about? Well, it's rational explanations of causes and mechanisms. And in order to provide rational explanations for causes and mechanisms, you do need objects. You need to have a thing, a mediator, okay, especially for the force of pull. Okay. On the other hand, philosophy, it is not what everybody thinks is philosophy, which is what everybody from, I don't know, Aristotle or Plato, all the way to Ayn Rand and some of the modern philosophers thought was philosophy. Now, we're saying philosophy is also rational explanations. But rational explanations of what? Well, we're saying it's rational explanations of reasons and purpose. Why someone does something. And it's bread and butter. It's a building block is the concept. Okay, so this is what we're proposing. This is how we look at things in this channel. And you don't have to agree. I'm just saying that's how we are going to look at it here. So when you bring things in here, you may be tempted to bring things from, you know, what people think in the past, what they thought philosophy was, and that's not what we believe or consider philosophy here. Okay, so keep that in mind. Okay, and just as a final point on that is that if you go to the Stanford Encyclopedia of what? Philosophy, the only word you won't find defined is the word philosophy. So we have no idea what that encyclopedia is about because they don't have a definition for the word philosophy. Don't take my word for it. Look it up. You'll find that the Encyclopedia of Philosophy does not define a philosophy. And so they don't have a definition or an analysis of what philosophy is. So since they didn't, I do. Okay, philosophy, rational explanations of purposes and reasons. Now we don't do purposes and reasons, you know, the whys here, why someone did something. We do the hows, mechanisms. Okay, we want to explain, because we do physics, we want to explain how the universe works mechanistically. And some people say, well, you can't explain that. There's no way. It's so complex. We cannot even imagine how it works. And here we take the opposite position. We say that the universe is so simple, even a baby can understand it. That's how simple it is. I mean, just think of it for a second, okay? What do we have out there? Rocks. We call them planets, asteroids, comets, stars. What are we talking? Gases. What are we talking about? We're talking about inert matter, just running around. You know, we have these stars called like our sun, and they have all this fire, okay, whatever that is, however it's created. And around them, you have all these planets going around. and and also asteroids and so on. How difficult can it be? We're talking about essentially a campfire and a pebble going around. Two entities. How difficult can it be? And the only issue there is that people can't see the mediators. Because if we had God's eyes and we could see the mediators, it would all be over. We'd say, oh, that's so simple. Kindergartners can understand that because we can see everything now. The only reason we ended up with mathematical physics and all the irrational explanations of mathematical physics, I hope I'm still online, is that we can't see the mediators. That's the whole issue. Gravity, when a pencil falls down, I like to do the experiment. Why is it magical? Only because you can't see the mediators. Same with magnetism. How many objects do I have? Just two objects. The two black round things there. Those are the magnets, and there it is. It gets stuck, and I like to do this. Separate them, and you can see I'm not pushing it. Okay, and as soon as I let go of it, it falls in there. There it goes. Okay, here it goes again. I let go of it. And so the only reason this is magical is we can't see the mediators. If we could see the mediators, this would be kindergarten stuff. We'd be laughing at ourselves. Okay, so this is the issue. The issue is that physics is about giving explanations of mechanisms, and in order to do these mechanisms, you need to identify the invisible objects that serve as mediators. And if you don't do it with some invisible object, thing, entity, body, substance, whatever you want to call it, you're in essence explaining with black magic. Okay? So it's that straightforward. Okay? So that's our position here. Anyways, we say there's been a major paradigm shift. No particles or waves. What we have is light and gravity are mediated by helical DNA-like ropes. What am I talking about? Well, let's just go slowly on this. This is the difference between what mathematical physics proposes and what the rope hypothesis proposes. Okay, we're just saying that all atoms in the universe, all atoms in existence, are physically interconnected. That's never been proposed by mathematical physics. Mathematical physics only proposes that there are discrete particles out there. It turns out that that's not even true. That was true only as long as classical mechanics was alive. Classical mechanics died at the beginning of the 20th century, especially in the 1920s, when they came up with quantum mechanics. And quantum mechanics does not use particles. They use the word particle to refer to concepts, abstract concepts, specifically the wave function. Okay, it's a number that somehow collapses and turns into a point, which is another concept because it has no length, width, or height. No, it's not 3D. It doesn't take up any space. It doesn't have any size. It's just a concept that turned into another concept because they're just going to do math. They're not going to do physical mechanisms. Okay, they're not going to simulate anything with physical mechanism. So those particles are really not particles, but that's essentially what they're talking about. And also, for your information on that, is that if you go to the standard model, which is the official version of mathematical physics, you won't find a single picture of any of the particles. You won't even find a picture in all of quantum mechanics, not of the subatomic particles. You won't find of the atoms themselves. And yeah, you'll see the little planetary model for explanations for everything, but as soon as you put a mathematical physicist against the wall and say, or against the ropes and begin pummeling him, and you say, okay, draw for me the quantum atom. Is this the quantum atom, this planetary model? And he'll say, no, it ain't. That's not our model. That's not our quantum atom. And when you say, well, what does it look like? Well, some will say that they've never seen one, they don't know what it looks like in reality, and it escapes their imaginations. Others will tell you, you got to take a course in quantum mechanics at the university level to understand what it looks like. Okay, those are the answers you get. Okay, and here's our proposal. We're saying that this is the single thread that all atoms are eventually not only interconnected, but what underlies them all is a single thread that makes up all the matter in the universe and the ropes that interconnect them. It's a single closed loop thread. Okay, and this is essentially what we're saying. We're saying that this single closed loop thread essentially coils up on itself. Okay, not that it started out this way, but we're just giving you the idea of how how the universe is built. Okay, and so we're saying that if you take the single closed loop thread and twist it on itself, eventually you end up with what you see there, interconnected atoms, which is what we're proposing. And there on the bottom left, you'll find the model, which is the basic model, which is two atoms connected by a rope-like entity that expands. The atoms expand and contract, and by doing so, they twist the rope, and that's going to be, and those torsions are going to be what we call light. Okay. This also helps us explain gravity, because now we have all atoms in the universe interconnected. And so you don't have really what is known as action at a distance. Okay, it's not that there is action at a distance, it's that we can't see the mediators that interconnect the atoms. Okay, and so yeah, it seems so this pencil is made out of atoms, but we cannot see the ropes that interconnect every one of these atoms to every atom that makes up the Earth. Okay, so that's the argument, that's the theory. Okay, and that's what you got to debunk. Okay, and you don't debunk. Let's see. Well, I'll get to some of your questions later on. Okay, I just hope I'm still online. Okay, so where does this take us? It takes us to definitions of two specific words that have never defined for the purposes of physics. Not a single book of physics, textbook of physics on planet Earth begins by defining what an object is and what existence is, what exist means. And physics is the science of existence. Physics deals with what exists out there, tries to elucidate what exists, especially in that invisible, intangible world of Mother Nature's Father Universe, God, whoever you believe in. Okay? And so we need to define these two words, object and exist, because they form the foundations of any physical interpretation. Okay? And so what is an object? It's not that which you can touch or see. It's that which has shape. Shape is a universal property of all objects. Okay? On the other hand, see and touch, you can't see and touch all objects or all things. We can't even see an atom. We can't, maybe we can touch it, but we don't know if we did or not. You know, depending on a hydrogen atom, can you touch a hydrogen atom? Well, you know, you go like that and you say, well, I don't know if I touched it or not, because you feel no weight on it or anything, you know, but for sure you can't see it. Okay? And we can't see the air. And you can't touch the table that's on the other side of the planet, let alone, you know, one on the other side of the universe. So that is an irrational definition. It's also an irrational definition. Why? Because you need two objects to see or touch. That means you need another object to define the word object. And then you have to define nouns before you define verbs, because only a noun, an object, a thing, can do motion. So before an object can see or touch, meaning it's going to move, it's going to do something, you have to have an object. And so again, you have to define the nouns before the verbs. You got to define the thing before the motion. Okay, so for those reasons, the definition used by mathematical physics and by just about everybody out there, see, touch, is irrational. Okay, and so all you can do is propose a definition for these two words, object and exist, and you got to defend them. You can't just say, well, majority of people in the world believe in it. That's what we've always used, you know, tradition. And that's what my teacher taught me, authority, you know, et cetera, et cetera. It doesn't work that way, not in science. That's the way it works in religion. Okay, so no, here you got to defend your definition. Okay, what are the typical rejoinders that people raise against the rope model? And here you have them. Okay, these are the typical ones, okay, that I have gotten over the last 13 years at least. Okay, and so it goes like this. See, that's the first one. You know, say, how come we can't see these ropes? Or they say, touch, you know, how do they avoid tangling? You know, you have the ropes, the gazillions of ropes. We're talking about an unimaginable number of ropes. In fact, that's the next one, quantity. Are you saying there are trillions and trillions and trillions of ropes crisscrossing around me? Yeah. We're saying that there are gazillions of ropes. Gazillions means, well, go figure out how many zeros that got. Gazillions. There's gazillions of ropes in the universe. In fact, there's gazillions of stars. Are you going to question the number of stars? And stars have tons of planets. You know, I think there are more planets than stars out there. Are you going to question the number of stars? And each planet, each star is made out of gazillions of atoms. Are you going to also question, you know, how many atoms are in the making up, for example, the Earth? It's gazillions. And so, you know, we're not used to these quantities. So whenever people suddenly, you know, wake up and say, oh, you're saying there's gazillions of atoms here on Earth? Well, yeah, have you just woken up yesterday or what? Yes, there are gazillions of atoms here on Earth, and nobody questions that. And now you say, well, there's gazillions of ropes crisscrossing. You say, oh, hold it, you mean there's gazillions of ropes crisscrossing? Yeah, that's what I mean. Just like there are gazillions of atoms, there's gazillions of ropes. And you say then, again, how do they avoid tangling? And I'll get to that in a minute. Okay, so let me continue. Other people talk about belief. They say, what experiment do you propose to run to prove their existence? The existence of the ropes. So we can't see or touch these ropes because they're intangible, they're invisible. But you want to go to the lab, run an experiment to detect them somehow. To say, there's the rope. What you're trying to do with your experiment is try to have God's eyes. And good luck with that one. No, you can't see them. But I'll get to that also in a minute. Okay, all of them together. I'll get to all of them together. Okay, some people troll and they say, what do you mean by shape? And what do you mean by mean? And what do you mean by the or by and? They just want to hound you to death, saying for you to define every word in the dictionary because you need this other word to define this one and so on down the line. And so, no, we don't do that in science. We don't care about that. We only define those words that are crucial. And the context here, especially in the context of object, is that we either go with a shape or we go with a see-touch. That's the only context. Because what mathematical physics uses, and what almost everybody out there, in fact, I think everybody out there, for example, the electric universe or the John Chappell Society, all these dissidents and the establishment, they all use the same notion, see and touch. And so we either go with see, touch, or shape. We do not need to know to the perfect, infinite perfection what see, touch, and shape mean. Okay, so it stops there. It's a question of which criteria you're going to use. Are you going to use shape or see touch? And if you've got a better criterion than that, like mass, volume, or whatever, bring it on. We can take care of you too. Okay, and then we have creationism. How did or do the ropes come into existence? They think that empty space, can turn into a physical object. Spontaneously acquire length, width, and height, and it turn into a rabbit or whatever. Okay, and in this case, the rope. No, space cannot turn into matter. Matter cannot turn into space. Period. We're done. That's a rational person understands that. An irrational or religious person, they don't understand that because they're in this world of spirits and energy and all this other stuff. Mechanism. So gravity is a stretching of ropes? Absolutely not. That's not how it's done. It's done by aggregation, and we'll get to that in a few minutes. Okay, but let's answer this with one fell blow. Okay, here it is. Okay, we have it here. Okay, why don't you ask these questions of Dr. Quantum and Professor Relativity? Okay, you say, how come we can't see these ropes? Well, how come we can't see these wave functions? Did you ever think about that? Did you ask the powers that be in quantum mechanics about that? How about touch? How can two particles be at the same place simultaneously? That's what quantum says. Quantity, are you saying there are trillions and trillions and trillions of particles and waves around me? Okay, how many waves are around us? How many particles? How come you never question quantum about that? Okay, how about belief? Well, we have, what experiment do you propose to run to prove their existence? Prove the existence of these wave functions that turn into particles. Prove the existence of waves. How do you prove that? I mean, you're going to go to a lab and say, yeah, there, I see it. I can touch it. Is that what it is? You're going to do it through see, touch? Is that how you're going to prove it? Definition, they say you're doing philosophy. Well, for that, you got to define what physics is and what philosophy is. And as we all know now, Stanford Encyclopedia of Philosophy, probably the #1 source in the world, does not define the word philosophy because they have no clue. Okay, they never thought about defining the word philosophy. Creationism, how did Big Bang come into existence? Okay, I mean, you say, how did the rope come into existence? We're saying it didn't. It was always there. But why don't you ask the people in Big Bang how they came into existence? And they'll give you the runaround. They'll say, well, it's an unscientific question. Because we can't prove how it came into existence. And about the mechanism, well, so gravity is the bending of a concept called space-time? Is that what you're just suggesting? Okay, so yeah, you got to ask these questions first of general relativity and quantum mechanics. When you finish over there, then you can come over here. Now, some people will say, well, I don't believe in quantum mechanics or relativity or whatever. I don't care. First, you go and attack them and show why they're wrong or irrational, like I say. And then when you come down here, show me first your theory so that we have a way of comparing, especially what's going through your mind, because we need to find out what's going through your mind in order to find out, if you're a rational person. And so first you got to propose your theory, your assumptions, and then we can compare notes. Okay, we'll compare your notes against my notes. And then maybe we can apply John of Occam, right? Occam's rule. or just Bill Gaede's rule of irrationality if you're moving concepts around or defining words in such a way that you can't use them consistently. Okay, so all these things have to go in that order. If you're going to attack the rope model, first attack quantum mechanics. Attack yourself. But if you say, well, I don't believe in quantum or in relativity, no problem. Then the first thing you got to do is show your hands, show your cards. We need to see your cards so that we can compare, the rope against whatever you propose. Very simple. Okay. So if you've got a different idea how this universe works, no problem. But you should be able to defend it. You should be able to first show your cards and then be able to defend them. Okay. That's the idea. Okay, a fellow comes over and he's a Flatlander, one of these Flatlanders. He says the following, he says, you're living on a flat, motionless plane. I'm wondering if he has a square for a brain, okay? A two-dimensional stick there maybe, one-dimensional, I don't know, it looks like a two-dimensional, okay? And that's his living quarters, his house. Okay, yeah, they believe that the moon and the sun are about the same size and they roll around each other. They're little balls in the sky, maybe a few kilometers away, and they just go around and around and around for no reason whatsoever. What can I say? Here's what they usually propose for gravity, which is the issue there, okay? And not everyone agrees. There's like 4 different theories from Flatlanders, but I think the main one is that they believe gravity is equal to electricity. In other words, that gravity is no different than electricity. Okay, and so no problem if that's what you believe, dear Flatlander, no problem. But you got to answer these 2 questions at least before you come in here and attack anything, especially making a baseless statement like that we live on a motionless plane, on a flat motionless plane. If you're going to propose electricity, first you got to show me how you pull with one-way flow of electrons, which is currently the notion that people have, at least mathematical physics has, electric universe has, and all these other, I think the John Chappell group also believes in this. They all think that in what's his name, Niels Bohr's planetary model, okay, of the atom, and they think that electricity is just a flow of electrons from one atom to the other. Okay, so how do you pull, if that's the case, how do you pull with beads going from in one direction? And then the other one is that even before then, you got to explain, or better yet, you got to draw, your model of the atom. Are you using the planetary model? And if you are, which is what mathematical physics uses, well, then you have to explain why that bead doesn't spontaneously fly out of the atom or fall to the nucleus. Okay, what keeps it in that yellow region, which are the orbitals or energy levels, whatever you want to call them, okay? What keeps them there? Why are they stuck in that region? Okay, so that's what you got to explain. And hopefully you show a physical object that connects your little bead to the proton, the electron bead to the proton bowling ball, as I call it, okay? You got to explain that, because if you cannot explain that, you cannot even talk about electricity, because you're not finished with your hypothesis. You're not finished with imagining your own atom. So your atom is the first thing you got to draw. And then from there, explain with your atom electricity. And then you can show, maybe, how electricity pulls on something. Very simple. No positives or negatives. We want to see a physical mechanism. You can't say, well, this is North Pole, that's South Pole, this is West Pole, East Pole. We don't care about that. You can say positive, negative, A and B, X and Y. We don't care. You got to show us a mechanism. So you got to show us what's happening at each pole, okay? And why, what causes the physical mechanism that causes something to be attracted to something else. For example, in this case, the pencil, apparently it's attracted to the center of the earth. It's certainly attracted to the table, but we all know that, if you do it outside, it falls, it tends to fall to the ground, to the center of the earth, never falls to the sky, right? You let go of it, and there it is, it falls downwards. And so you got to explain with your electricity without using positive and negative, right? No energy, no concepts, no fieldy thingy, no massy thingy. You got to explain with physical objects. You got to draw your physical mechanism. In fact, you should keep your mouth shut and just make a movie of your physical mechanism. We watch it, we should explain it. Just like someone who would explain why the window broke, and he makes a movie of a brick going through the window, and we say, okay, we know how the window broke. The brick went through the window, broke it, we're done. That's what we want. That's what we're looking for. A mechanism of how the window broke. This is the same thing. We want a mechanism of how that pencil fell to the table. It all has to be illustrated. Video is even better because it's a dynamic thing that happened, a phenomenon, okay? So we want to see a mechanism. Don't talk to me about energy. Don't give me any equations. Don't talk to me about positive and negative. We want the mechanism. A movie with everything identified, all the objects identified. Okay? If you can't do that, if you're just going to say, well, here's the equation, here's the concept that did it, you're doing gravity, you're doing physics with black magic if you have no mediator. Okay? So I don't care if you push it with particles or what, no problem. But they better be particles, real particles. Don't tell me it's a concept that pushed on the pencil. Okay? That's the point. Okay, here's what a person who wants to explain gravity, like in this case, the Flatlander, he said that gravity might be electricity or whatever. This is what a person who tries to explain gravity has to explain. And this is Mr. Richard Muller. He's a professor, or was, I think maybe he's retired now, I don't know, emeritus, from Berkeley. And this is one of his classes, and this is what he says about what a person who has to explain gravity, right, has to explain. You know, this is what you got to explain. Here it is, okay? Give me a second here. Let me turn it on, okay, because this is going to be Mr. Richard Muller speaking. Here it goes. I hope you can hear him, okay? I hope I'm still online. Here it goes.
The force of gravity is actually a force of attraction between mass. So, for example, if you have the Earth with its big mass here, and you have you with your little mass here, that every atom on the Earth is pulling on every atom of you. You're also pulling on it. On the other hand, there are a lot of atoms here you're pulling on. You're pulling on all of them. The amazing thing about gravity is it goes right through things.
I hope everybody heard that. Okay, please let me know if you didn't. Okay, I hope you heard Mr. Richard Muller explain to you what needs to be explained. And here it is in summary, okay? This is what he said, essentially. He says, for example, if you have the Earth, there's a big mass here, and you have you with your little mass here. Every atom on Earth is pulling on every atom of you. You're also pulling on it. The amazing thing about gravity is that it goes right through things. That's what you have to explain. Okay, so you have to explain what mechanism you propose, physical mechanism, where gravity goes through things. You know, you can't put a shield in front of you to protect yourself against gravity. Okay, and then the second one is that what you need to do is explain how every atom on Earth is pulling on every atom of you. Okay, do we have that? Okay, you have to explain two things. Okay, let's see if we got it straight. How gravity goes through the wall. You have a wall in front of you, it doesn't help you. You know, you can't protect yourself. Like, you know, if there's a wall and you're falling behind the wall, gravity will pull on you and the wall together towards the center of the Earth. Like if you're falling from an airplane and here's the wall below you and you're behind the wall, you say, well, I'm protected because gravity can't reach me because the wall is there to protect me. No, you both fall. You cannot put a shield in front of you to protect yourself against gravity because gravity goes through things. So you have to explain that, one. And the other one is, how is it that every atom on Earth pulls on every atom of you? Do we have that? Okay. And so under the rope model, here it is. Okay. Here's a dynamic version. Okay. There you can see it. It's going to start in a second here. Give it a second here so it starts from the beginning. Okay. You're trying to leave the Earth with your little spaceship, and your ropes are extending, and you can see what's happening to the ropes in general. Okay. What's happening essentially is all the ropes converge upon a point, and it gets elongated. And here you see it, the angles. Okay. Give it a second here. You look at what's happening to the angles of the ropes. Okay, that's what we're saying. That's the argument. That's the theory. Okay, so let us start at the beginning. You see what happens to the angles there. With the red lines, you can see what's happening to the angles. Okay, as you get farther and farther from the Earth, the angles of the rope approach 0, or you can say even 180 degrees. Okay, so that's the theory. Okay, you know, close by, the ropes fan out. Farther away, all the ropes come together and gravity is weak. So as you approach the Earth, You have an acceleration of gravity because the ropes are fanning out, meaning they're not superimposed upon themselves, because when you were far away, they all formed a single coaxial almost. And as you approach an object such as the sun, a celestial object, the ropes fan out, and now your acceleration is faster, faster, and faster, and faster. And remember, every atom in your body is connected to every atom on Earth. So this is the idea, okay? And so this morning when I woke up, I decided to I loaded up a little song for you, okay? It's a little song, and I want you to hear it because it'll help you remember of the fact that all things in the universe are interconnected. It's got to do with this little fellow here, okay? Okay, I hope you can see him, okay? Okay, and so we're going to explain gravity, or better yet, interconnectivity, okay, with this little fellow, okay? And so I created a little song for you, and I want you to listen it. You should sing the song every day so that you remember the rope hypothesis, okay? And here, let me turn it on in a second here. Here it goes, okay? Listen carefully, here it goes.
Well, your toe bone connected to your foot bone connected to your heel bone connected to your ankle bone connected to your leg bone connected to your knee bone connected to your thigh bone connected to your hip bone connected to your back bone connected to your shoulder bone connected to your neck bone. I hear the word of the Lord.
Okay? So if you remember to sing that song every day, you'll know that everything in the universe is interconnected, just like your whole body is interconnected. One thing is connected to the other one, okay? And as long as you have physical interconnectivity across the universe, you can explain action at a distance, because there is no action at a distance. It's that everything is physically interconnected. Okay, so let's get on with some of the questions people raised. And they have to do a little bit with this extinction thing, which we also do on this channel. Okay, we did it throughout this whole year. What do we propose? We're proposing that we're the last humans on Earth, last generation of humans on Earth. We don't have too long to go. Okay, I don't know when it's going to come down. Hopefully, it's not in the year 2022. Even though there are some hot spots in the world that could create incidents that get out of hand. One of them is in Taiwan right now, and the other one is in Ukraine. And so we have to keep a close eye on that and just pray, hope that the politicians and the military, reach an agreement at the negotiation table and don't go for their holsters, okay? Let's just hope. For otherwise, this will be the last year, okay? Okay, so this fellow says, the first step of your hypothesis is social. The human loses trust in each other and the trade ends, okay? Once the trade is over, billions of people will die of hunger, starting from the mega metropolises. The coup de grace occurs for genetic causes, that is, the systematic reduction of genetic diversity. Genetic diversity is critical for a population to adapt to changing environments. Wonder where he got that. If a highly selected and low diversity strain like fish populations grown for aquaculture is introduced into the wild population, it will reduce the population's ability to adapt to changes. Okay, so that's how he starts. He continues here. He says, your hypothesis is that an overwhelming change that leads to billions of deaths in our species will mean that the remaining ones will have to adapt to the environmental change. Okay? I want you to listen to these words that he's using, okay, like adapt, the ones that I underlined, environmental change. What is he talking about? Or from a modern technological environment to an older, more natural environment. And this will crush it, bringing the human species to extinction. Planned extinction. The word planned means that DNA is by nature programmed to destroy itself in a species if this has been replicated for a certain number of times and for a certain number of laps around the sun. Tell me, Bill, what did I not understand? Well, what can I say? This poor fellow didn't understand anything. I mean, he didn't get one right, okay? So obviously he's got a major problem in understanding. I think part of it is that English is not his first language, so that's understandable from that point of view. But this is more than that. I think he's not listening. He's not, it all goes from one ear to the other and there's nothing in between to stop it. Okay, so this is where I start. I'm saying people like that needs to be educated, okay? And so we have to find out what his problem is. And his problem is that he better understand quickly, because otherwise one of us two will die. And here we have Mr. Faulty, for those of you who know him, okay? And he's going to tell it like it is, okay? So give me a second here, okay? And here goes.
Now, please try to understand before one of us dies.
Let's hear it again, okay?
Now, please try to understand before one of us dies.
And why not one more time?
Now, please try to understand before one of us dies.
Okay, so please try to understand before one of us dies. Okay, and how do we cure that? When people have problems in understanding, we do have a method for curing that on this channel. Okay, and we'll let Mr. Faulty, explain that to us as well. He's gonna do it with his car. He's gonna explain it to his car, how he disciplines his car.
Right! That's it! You've tried it on just once too often! Right! Well, don't say I haven't warned you! I've laid it on the line to you time and time again! Right! Well, this is it! I'm gonna give you a damn good thrashing!
Okay, so that's how we teach people. In fact, we have the bgaede School of Physics, right? And this is our motto. Here it is, okay? The bgaede School of Physics, we teach with a baseball bat, okay? So just be aware, here a baseball bat is too big, so what I use is my dough roller, okay? That's how we teach here, okay? So yeah, sometimes we need to use a little bit of physical involvement so that people understand. Okay, so let's get on with what this fellow said. He said, first step of your hypothesis is social. So we have to educate him on the first line itself, okay? What is a hypothesis? Okay, and here it is, okay? Okay, here it is. Science is about rational explanations, okay? Scientific method includes hypotheses. What are hypotheses? They're assumptions, okay? They include the objects, the definitions, and the statement of the facts. Essentially, the initial scene, the first frames of your film, okay? Because that's your starting point for your theory. So a hypothesis includes the objects, definitions, and assumptions about what happened. What is a theory? Hypothesis is not a theory. Theory is not a hypothesis. They have nothing at all to do with one another. A theory is an explanation of how it happened in the case of physics, right? The mechanisms and causes. In the case of philosophy, it's explanation of why it happened, purposes and reasons. A hypothesis sets the stage for the explanation founded upon it. Okay? So what you have to understand is that your notion of hypothesis is already irrational. And if you look it up, you'll find all kinds of definitions for the word hypothesis. One says it's a prediction, another one says it's a theory, another one says it's an assumption. They've got all these different notions of what a hypothesis is, the questions you have to ask, a whole bunch of stuff that has nothing to do with a hypothesis. Okay, hypothesis is the set of assumptions, and they include the objects, in case of physics, right? The objects, the definitions, and your starting point, in other words, the initial scene or your statement of the facts. Not the facts, because we don't know what the facts are. Mother Nature knows what actually happened, but she's got that in her file cabinet. We have no way of reaching the file cabinet. All we can do is make a statement of the facts of what we think the facts are. And again, you have a prosecutor and a defense attorney, and sometimes they won't agree on what actually happened. And that's what we're talking about. Each one has his version of what happened, and based on that, of what they think happened, on that is what they're going to base their theory, their explanation, their case. Okay, so that's the issue. So first learn what a hypothesis is. Okay, so that's the first one. Then he says, a human loses trust in each other and trade ends. Absolutely not. That's not what this is about. Okay, so this is what we put in there. We say that first, a hypothesis is not a theory. Okay, and then trade does not die because of trust. Okay, it's got nothing to do with trade, with trust. The fact that trade dies. It has to do with the global economy cannot grow forever. So get it right. It has nothing to do with trust. We're talking about trust in money. People will lose faith in money once the economy falls apart, because what does that mean? It means money is no more, money has no value, and because of that, people lose not faith in other people, but they lose faith in the dollar, in the euro, in the money itself, even in Bitcoin for the gold, whatever. Okay, so that's the issue. And then the other issue is the coup de grace for genetic diversity. He says genetic diversity is critical for a population to adapt to changing environments. Not in this channel. Not in this channel. So please do not mention that ever again. That's only true in the world of paleontologists and geneticists. And we're saying these people have no clue whatsoever about anything. Not a single geneticist on planet Earth, not a single paleontologist on planet Earth ever figured out how extinction happens. Here we are 200 years later after George Cuvier invented the discipline, and not a single geneticist, not a single paleontologist can tell you how species disappear. And even worse than that, in the case of geneticists, what is a geneticist? Geneticist is just a bean counter, or what Mr. Rutherford would say, he's a stamp collector. You either do physics or you do stamp collecting. A geneticist is a guy who knows how to count atoms, maybe molecules. He can tell you something about chromosomes, but he can tell you what he sees there. He sees through the SEMS, and he comes up with these machines that can read all that stuff. He doesn't even need to read them himself, and he counts base pairs. And so far he's a bean counter. So far he's a lab boy. He's a technician. He's not even an engineer. Okay, an engineer is a scientist, or supposedly. He's supposed to be. And a scientist is a guy who explains. He's got to figure out what actually happened and how to explain what happened. And what did the geneticists come up with? Well, they say, we found 2% commonality between Neanderthals and humans, and so the reason they disappeared is they had sex. That's the kind of answers geneticists give you. Svante Paavo at the Max Planck Institute, he's the guy who created that theory. Essentially, he didn't create it, but he's the guy who made it popular, and that's the ruling theory for how Neanderthals disappeared. And so, yeah, all these paleontologists, geneticists, they have no clue whatsoever about their own disciplines. So don't put their words in my mouth, okay? So it says genetic diversity. This adapt to an environment, the fact that all they come up with is that, yeah, you need to have, like, if you have inbreeding, the problem with that is that you're going to be more susceptible to environmental changes or to diseases. That's not what we say in this channel. Get that straight. That's not our argument. That's not our theory. Okay? What is our theory? Inbreeding produces retarded children. That's in a nutshell. Okay? It's a little more involved than that. But just so you can see the difference. We're saying that you can't continue inbreeding like humans have for 200, 300,000 years and expect to produce children who come out physically or mentally sane. At some point, you're going to have, what do we have? We have Siamese twins, people with two heads, two elbows, whatever. I see them in plants. I raise plants, and I saw 5 in one of my peach trees, 5 Siamese. And why? Because we are forcing them to inbreed. In fact, in some cases, like we're trying to produce seedless grapes, and what we do is we just cut. If you've seen how grapes are grown, it's just cloning. That's what it is. You take a branch from here and you plant it over there. That's how grapes are being grown. And so we're liquidating all that stuff very quickly. We're helping them achieve this point where they have no genetic diversity because they're all clones of each other. You can continue cloning humans or anything else and expect not to have retarded children after several generations. That's what happened in Calhoun's experiment. It's what happened to the Amish. The Amish, after 300 years of inbreeding, right? They were not completely free when they came to America, for example, in the 1600s. They were already part of the human race, and they had been around for 200,000, 300,000 years. Now here they are. They go into these little communities, and they start having lots of children over the centuries. And guess what? Now they're having mental and physical problems. Kids being born with 6 fingers. So this gives you an idea. You can't have inbreeding because it results in retarded children, in physically handicapped children. That's the issue. It has nothing to do with the environment. It has nothing to do with diseases, with what you eat, with climate change, with peak oil, none of that. It's got only to do with the fact that you can't inbreed because you're going to have retarded children. You don't have to believe it. That's the argument. That's the theory in this channel. Okay? We're not asking you to believe it. We're asking you to understand that we're not talking about adapting to the environment or diseases or whatever. Okay, so you got to understand that. He didn't understand this either. Okay, and then what was this other argument here? Well, let me show you first. This is Calhoun's experiment. Okay, and again, he showed in a very short while, period of 2 years, how 8 mice, 4 couples, which is what he started with. This was the founder's effect. Okay, he put 8 mice, 4 couples in a closed pen, which was about, I think it was like 2 meters tall, maybe, and about 2 meters all around, 2 meters by 2 meters by 2 meters by 2 meters. Okay, so it wasn't very big. And in there, he put these 8 mice, and they just reproduced. And by the time you get to, like the middle generations there, after about a year, there were about 2,000 of these mice, all from the same stock, from the same parents or grandfathers. And eventually, they ended up falling all the way to extinction. Why? Because they did not reproduce. Well, here's a summary, okay? Here's Calhoun's summary, okay? Mice became autistic. They became homosexual. He's, I think, the first one, or one of the first ones to produce homosexuality in the lab. Mice lost interest in sex. Females weaned their offspring early, and a lot of their children were killed by others. Females became more aggressive, and mice became more violent in general. And so Calhoun, he was a psychologist, he concluded that the experiment was an analogy for what is happening to humans. Look around you, you'll see these same symptoms in our society. And of course, a lot of psychologists out there say, well, we're different than the mice. We're not the same as all these animals. Why? Because we have intelligence. They think that makes a difference. Okay, maybe it does. I don't think it does. Okay, the fact that we have all these the fact that we can foresee events, the fact that we have intelligence, we have technology. People think that's an antidote to extinction and to these types of problems. They're not. Okay, the cause of a mass extinction cannot be overruled by intelligence, by technology, by the ability to foresee events and react to them. Nothing humans can do to change extinction, the extinction of man, mass extinction. Okay, that's the argument in this side again. You don't have to believe it. That's what we argue here. And then here we have, he says, your hypothesis is that an overwhelming change that leads to billions of deaths caused by environmental change. Again, nothing to do with that. But then he says planned extinction, like saying, like there's some kind of God or Mother Nature, whoever planned it, had a purpose, already planned it in advance, and says, oh, we're going to make sure that, in this case, he's saying the DNA by its nature is programmed to destroy itself. No, that's not what it's about, okay? Absolutely not. We're not saying that that's going to happen. What we're saying here is something else. We're saying that, first of all, we're not going to die in a background extinction, which is, the genetic diversity / overturning of the population pyramid. Those are the two mechanisms that cause a background extinction. We humans, right? Our species is going to die, is going to disappear in a mass extinction. That has to do with food. Why does it have to do with food? Because we produce food thanks to money. What's that got to do with money? In a sense that, well, the global economy cannot grow forever. And at that point, you can't just keep producing money, which is what we're doing now. This is the monetary aspect, the monetary policy that all these governments are implementing. They're just creating money. And by creating money, all you're doing is diluting the salary of those who collect salaries and wages. And so what happens is at some point, a lot of those people will have no reason to go to work, which is already happening. But, what happens is a lot of those people will just barely make it to the end of the month. They'll be able to pay their rent, their food, and that's about it, and go back to work the next day, which is the life of a slave. It's a better slave than the Pharaoh had, for sure, no doubt about that, but still a slave. That means the guy can only go to work, pay his rent, put some food on the table, and go back to work. And there's more and more people in that category. And the more money they produce, the nominally means the less real value money has, and that's eventually going to affect the entire world. And what's going to happen here is that, at some point, especially the United States government, which is the American empire, all I'm saying is all that needs to collapse is the American empire. We don't need to have Europe collapse. We don't need to have China collapse, Russia collapse. All that needs to collapse is the American empire. Once the American empire collapses, not if, but once it does, that's it. China can't sell, Europe can't sell, they die, and the whole world collapses suddenly. And the collapse is going to be exponential. And what do we mean by collapse? It means that it's very swiftly, people realize that money has no value, that it's just either a number printed on a internet server somewhere or a little piece of paper that you carry around. And any of those will have no value whatsoever. You will not be able to trade that, that currency for anything else. Bitcoin, same thing. Gold, same thing. You can bring a pound of gold and people say, I don't want that stone. I'd rather have my banana. Because a banana will be worth more than all the gold on planet Earth. Because money will be no more. No one will accept it because he will not be able to get rid of it because the next guy won't accept it. Okay, because what are you going to trade it for? Money? So no, it's the currency, the medium of exchange that disappears. When that does, nobody has any incentive to produce food for the world, to distribute it to the cities. The cities massively die because no one produces or distributes food. Whatever food that's on the planet, we all scramble for, and that's not going to last very long. Maybe a few months at the most. And that's it. And after that, we start killing each other, and we begin hunting humans. Okay, that's going to be the last food, cannibalism. Okay, so that's what we say that's going to happen here in this site. Okay, believe it or not, we don't care. The point here is that that's the argument. Okay, fellow says, even if we had completely services-based society for humans with robotics and AI doing all the manufacturing-style labor, we would still have an economy. The few people, 1%, who dominate the 99% will not let a full economic collapse happen. And he just essentially repeats that in the rest of it. He's saying that the rich people, those who dominate, the elites, the Illuminati, the New World Order folk, the filthy rich, any way you want to think of them or call them, he's saying those will not allow the economy to collapse. And my argument is that it doesn't matter what they want to do. It's what you can do. See, this is not about being a Republican or Democrat or a communist. This has to do solely with one issue, and that is that humans have no solution to global economic collapse. We're headed that way. We're buffalo streaming towards the edge of the precipice. We're getting to the edge of the mountain, okay? And we're rushing there, and there's nothing that we can do about it because there are no solutions. The elites have no power to change what's coming up. They can create all the money they want. They can, juggle anything they want, do their juggling act. It doesn't matter. They will not be able to solve this problem. This is not a problem that humans can solve. This has nothing to do with intelligence, with foreseeing events, being able to react to it. So it's got nothing to do with intelligence, technology, etc. Nothing that humans can do about this. It's going to happen. Okay, the collapse of the global economy is a done deal. We cannot avoid it. And so this notion that the rich people will not allow it to happen because they would lose their status, their privileges, it doesn't matter. They won't be able to do anything about it. Okay, fellow continues here, and he says, spreading speculative fear porn about the future. Billionaires have put themselves in space, many probes and rovers paving the way towards colonization of the moon and nearest planets. He actually believes that we're going to go out into space and, colonize the planets first and then maybe the stars. Is that what it's all about? I don't think so. I don't think we'll ever get off this planet. And, for me, it's very easy. First of all, we can't get to the nearest star. We can't get to the nearest star because it's 4.3 light years away. That's a measure of distance. Round trip, you're talking about 9 years. And that's if we could travel at the speed of light. But let's concede that just for sake of argument, no problem. And 9 years, I don't think nobody will take that trip. And to go there and see another star system just like ours? And begin to colonize, maybe with robots, right? Maybe we send the robots first, let them do the trip, right? Okay, fine. And they go over there and they build the planet, whatever planet they find, the third rock from the star over there, whatever it is. And it turns out that it has some material, some CO2, and they turn that into oxygen. Great, now we can breathe if we go there, right? So we're going to make the trip all the way down there, right, to this place. And for what? Are we going to have commerce with that planet? Every 9 years they send us bananas or wheat or or maybe iron. Is that what it's going to be about? And it turns out that here on Earth, our population is declining. In other words, it's increasing, but the growth rate is declining, meaning if everything goes according to plans or according to how it's going now, mid-century, we get to zero population growth. So do we have enough land on the planet for more people? Absolutely. We could put 1 trillion people on the planet. We're only 8 billion people. We could put 1 trillion people on the planet. 800 billion, 100 times more than what we have now. We could put on the planet physically, okay? Well, let's not talk about resources yet. We're just talking about land, space, right? There's enough room for all of us. We do not need to go to Mars. We do not need to go to Venus. We do not need to go to Pluto or even beyond. We have more than enough space here on Earth. Now, resources. Well, we also have resources. And resources really is like Mr. Friedman, Chicago School of Economics, said, it's a question of money. For the right amount of money, someone will produce it and distribute it, sell it. Okay, so we don't have a problem. We don't need another planet. We've got more than enough space and resources right now for the planet as it is, foreseeable future. Maybe new technologies of some kind can extract more oil from the ground if we need more oil. Maybe we can produce more food if we need more food. Okay, there's a lot of things that we can do. Okay, we can turn the Sahara Desert into a lettuce-producing garden if we want, under the right conditions, under the right technology. Okay, so all I'm saying here is that we have enough space. We can create enough food, given if we have the right amount of money, etc., for that food that you're selling. We don't need to go to another planet. There is no reason whatsoever to go to another planet, aside from the fact that I doubt very much that we can get to Mars, but assuming we could, because that is within the possibilities, okay? I think we have the technology to get there. Whether we will get there is another thing. Maybe extinction catches us by surprise a little sooner than that. But if we go to Mars and put a station there, so who's going to live there? 5 guys, 10 guys, 10 astronauts, maybe 20? What are they going to produce? Potatoes, like the guy who got stuck on Mars and started planting potatoes there? Is that what we're going to do? Are they going to import them to Earth back again? They're going to trade? Think about it. Why are we going to build a station on Mars? Are we going to terraform Mars and live there and breathe the oxygen on a planet that has much less gravity, which holds less air around it? Assuming we could create the air, right? Let's concede all these points. So we create air. It's going to hold, the gravity is going to hold less air around the planet, a thinner sheet of air, meaning you're going to have less pressure. Okay, a lot of things are going to change. It's a planet that maybe is a quarter of the volume of Earth, So, I mean, are we going to move to Mars when we don't need it because we have all the space and resources we need for the upcoming generation here on Earth? So, no, it's never going to happen because going into space is an irrational proposal because it means that they haven't even thought about the fact that we already have everything we need here on this blue planet. Okay, so that's the issue. Okay, fellow says, I said this, can we run the world on entertainment? Because everybody's now moving on to into the internet. We're leaving even the services that are, hands, operated by hands, like barbering, landscaping, for example, restaurants, hotels, you need people who make the beds and so on. All that is disappearing, and where are people going to? Well, they're moving on to the internet. They're all creating internet jobs. Okay, you create this and that, and you create ads, and you get a check every month from the company that pays you because you put some things that people like, and they all give you hits, and you get all these this income from hits. And so everybody's moving from hands to abstract internet, which is primarily entertainment. And I was saying that, can we run the world on entertainment, meaning on internet alone? And the guy says, as you can understand, half the population of the world, China, India, Russia, Japan, etc., they produce as usual, and they think about entertainment as usual. The entertainment is belonging to the ignorant people of the European continent and, of course, our cousins in the Americas and Australia. And no, I don't think that's the case. First of all, the entire planet, China, Japan included for sure, are into internet. And they're into entertainment. I mean, obviously you haven't been there, you haven't gone to these places or even looked at their videos. Maybe you should do a little research on what's popular in Japan, and you'll find out that they're even more advanced on entertainment than even the United States. India, have you ever heard of Bollywood? Or maybe it's just misspelled. Maybe it's just Hollywood that they didn't know how to spell very well. So look it up. You'll find that entertainment is alive and well across the planet. I came from South America a little while ago, a couple weeks ago. And entertainment is just as big over there as any place else. Internet is taking over the world. the entire planet, every country. Okay, everybody wants to go in the internet because it's a fast way of making money. Bitcoin certainly stimulated that as well. You know, everybody now is betting on all kinds of coins out there, crypto coins. So that also takes people out of jobs and into this speculation. You know, casino and at home, you can pull the one-armed bandit at home. Okay. Paul says you don't do predictions in science, meaning, you know, that's what we say. We don't do predictions, but you predicted extinction in this very video. Okay, it's not that it's not a prediction, and sometimes it's very hard to get that through people's heads. The extinction theory is an explanation. That's what a theory is, and you can only explain the past. So it's not a prediction. It's got to do with the past because you're focusing on the wrong issue. The issue is explanation of the mechanism of extinction. Okay, so we're explaining the past. We're explaining how the dinosaurs died. We're explaining how the archosaurs died. We're explaining how the Ordovician animals and the the Carboniferous amphibians and the Permian synapsids died. That's what we're trying to explain. We're trying to explain how animals in the past died. And then we project this mechanism. Mechanism, word mechanism, keep it in mind, mechanism, okay? We're extrapolating this mechanism to humans and saying, can they avoid the same problem, which is food? And it turns out they can't. And so we're saying that because they can't, humans are going to disappear the same way that the animals in the past died in mass extinctions. Okay, we got it? Okay, no prediction. This is not about prediction. Predicting would be if I say, look, on the 1st of May of the year 2030, humans are going to die. They're going to disappear. The last human is going to die on that day. I can't tell you that. I don't do predictions. Okay? I do explanations. I tell you mechanisms. That's what this site is about. As long as you stay there, I won't hurt you. Okay, we got that? Okay, another fellow says, speak for yourself, old man. I'm starting to suspect Bill just hates to think people will go on just fine without him. In other words, you know, when I die, humans die because, yeah, in a sense, all existence dies because I died. Okay? His Scrooge-like personality demands everything ends when he ends. Well, yeah, that's a valid point. Okay, it could be that maybe I'm overdoing it. Maybe I'm just a little pessimistic. Okay, and I'm saying, well, yeah, you know, since I'm going to die, I think everybody should go with me. And essentially, that is the case because when I die, as far as I'm concerned, you're all dead too. You no longer exist for me, right? So yeah, you can say that Bill, because Bill is close to the end of his life, then maybe that's where he got the idea that, you know, extinction of man is also near its end. Okay, it's a valid point. You can consider, you can factor that into your decision whether to believe in the theory, but we're talking about a mechanism here. The point here again is mechanism. As long as you focus on the mechanism, I promise not to hurt you. Okay. So please keep your eyes on the mechanism. And in that sense, it doesn't have anything to do with me. The other thing I'm going to say is that I've been peddling my theory for 20 years. I wasn't expecting to die, 20 years ago. I didn't think I was that close to my own extinction. So no, this extinction theory has been around for 20 years, and I've been putting it on the internet at least since, 2008, 13 years, just like my rope hypothesis. So you got to factor that in as well. Okay, final couple points on the extinction things here. Person says, talking about homosexuality, okay? He's saying that it's learned. It's a question of nature versus nurture. Some people believe homosexuality is a nurture issue, not a nature issue. You're not born that way. You're educated that way. And he says, bamboozles numerous young boys whose sexual development is then tilted towards homosexuality. So he's saying that here comes this guy who's already homosexual, and because he rapes or fondles or whatever a kid, the kid becomes homosexual as well. That's what he's saying. It is spread through sexual contact, specifically when an adult male bamboozles an immature male. Well, I take a different view. My theory, or the assumption that I make, is that this is a genetically related issue, that after 200 to 300,000 years of inbreeding, we're going to get garbage out of women's wombs. So my only suggestion is women should not have children, because today we're all clones of each other, more or less. And the chances of getting a kid that is born wrong, both physically or mentally, sometimes both, right, are great. And especially if you have them at an older age, especially if your husband has problems with, the fact that he's got a low sperm count, or they're not very active or whatever. He's got problems with his sperm. Lots of problems with that lately. So right now it's not a good time to have children, right at the end of humanity, because first, that kid's probably going to meet an early death, and you don't want to see your kid die probably. And you might have to eat them before your neighbor does, just like I said, okay? And the other issue is more than likely you're going to have a kid that's born wrong, okay? So what can I say? I can only recommend in that sense, okay? But yeah, I'm saying that inbreeding leads to homosexuality. It's primarily a genetic issue. It's got nothing to do, or very little, if anything, to do with education, with someone raping a kid, or the kid being exposed to homosexuality and starting to like it. And think of yourself. If you're heterosexual, a normal person, and how did you learn? Did they teach you to like, if you're a man, right? Did they teach you to look at girls? Or was that like, it came by itself? I can tell you my experience. My experience is, I was attracted to women for a very, very young age. And so it came naturally. No one taught me, okay? Neither my folks, neither at school, neither the kids in my, that were my friends and so on. No, it just came naturally, okay? I don't know how to explain that. It was inbred. Okay, fellows, can you talk about nuclear weapons? Are they real or just made up? As after the atomic bombings of Hiroshima and Nagasaki, both cities were repopulated very quickly when it should have taken over 1,000 years for them to become safe. There are people who still do not accept that the bomb was dropped over these two Japanese cities. They don't believe, a lot of them, maybe not the same people, but a lot of people out there don't believe we went to the moon. And I guess you'll find people who say, no, JFK never existed. That was made in Hollywood. The two towers, really, including Building 7, right, which is more important, really. But they're still there. I went to New York the other day. I saw them there. They never came down. That's a movie that they put in Hollywood. So they don't believe a lot of this stuff. And much less are they going to believe stuff as you go farther back in history. Yeah, they might even say, well, Hitler did not exist. Stalin did not exist. Mussolini did not exist. That's all nonsense that they teach us. It never happened. It's the elites who are trying to brainwash us. So this is what some of these people believe. Okay, that's what they have in the back of their mind. Well, I'll give them an answer anyways. Okay, here's one answer. Okay, that might help you straighten this thing up. First one is that there are lots of pictures of these two cities after they were bombed. Okay, and the other thing I want to mention to you is that Japan surrendered immediately after Nagasaki was hit. I wonder why. Maybe you can answer that question, okay? Why did not the Japanese surrender so quickly when they were fighting tooth and nail to the last moment? And suddenly they dropped these two bombs. The first one shocked them. The second one say, oh, we're not going to have all of Japan destroyed. And so the king, the emperor, he took a decision, says, okay, we surrender. They brought out the white flags. And Tojo, he committed suicide and so on. Okay, he was running the show. Okay, but here's your answer, okay? And it comes from, I think it's The Guardian from London, an article, and this is what it says. It says, weeks after Hiroshima felt the unforgiving force of nuclear fission, nature compounded the city's misery. Makurazaki, an unusually powerful typhoon, swept through the city on 17 September, flooding large areas and ruining many of the temporary hospitals set up on the outskirts. The only good thing that came out of it was that it washed a lot of the residual radiation into the sea, says Tanaka. After the typhoon, radiation levels fell considerably. And then the same article later on says the cancer rate among elderly A-bomb survivors is high. So they did have cancer. Okay, many A-bomb survivors have been fighting various cancers and other illnesses typically caused by radiation, such as heart problems, cataracts, and leukemia. Right? There are very few survivors who have not experienced health problems as they've grown older. So yeah, the radiation did hit them. They stayed in the city. And just in case you missed it, there was another explosion, nuclear explosion, one in Japan, okay, a couple years ago, was it? And the other one in Russia, okay? And people are still living in those regions. Now, are they going to have cancer? Yeah, very likely. In fact, some people who apparently, there's a theory that some of the actors who did a movie near Nevada, I can't remember now all the little details, but they did a movie over there, and they were near a testing site for nuclear weapons by the, I think it was the U.S. Army. And just by sheer coincidence, a lot of these actors later on, famous actors, later died because of cancer. And so people say, well, all these people were in that movie, and they all died of cancer. And it was when they were close in this little town that was close to where the testing site was. So you figure it out. Yeah, the fact that you don't see the radiation doesn't mean the radiation goes through you. Again, see, touch, forget about that. You know, there's something hitting your atoms, and it better be a physical object. Okay, we call that the rope. Okay, fellow says electricity isn't an object, yet we can weigh a charged battery is more than it does. It weighs more charged battery than it does discharge. So what does that mean? Does that mean that because of that, a battery, this thing we call energy, whatever it's got in there, the charge, is that a physical object just because a battery weighs more before and after? I mean, what does one thing have to do with another? Are we going to define charge as an object because, or are we going to define the word object as that which weighs? Is that the definition of object? Okay. And do we have to weigh it? In other words, it's not the table that the Klingons have is not an object because you can't weigh it. And until you weigh it, it's not an object. Is that your rationale? So no, you can't say that because a battery weighs less when it's discharged than when it's charged, that the difference is this thing you call energy, and because of that, energy is a physical object. That's not a good rationale. Not at all. It means you got a problem, guy. Okay, and see, I've got this. These individuals in general, you know, they believe that, you know, same rationale. They think that because, you know, you apparently weigh more when you're alive than when you're dead. They say the difference is the soul, and the soul has weight, and therefore, because it has weight, it's a physical object. Same rationale. Okay, and so they have. This is from traditional religions, right? This notion. And they never identified the objects because in order to identify an object, you have to have a shape. You have to point it. You have to illustrate it. They never thought about that. They just thought in the abstract and say, oh, I see a spirit. And so they have these notions. Here, I'll show you a couple. Okay, these are the notions they have. You know, they say that when a person dies, okay, you have the spirit come out of their bodies. And they say it flies away. And so that spirit has weight. Because now what's left behind weighs less, and so what left was something that weighs more. And here you have another one. You have these spirits that fly around, okay? And people believe in this stuff. They believe in these spirits, and they call them energy. They have all these notions for it. Here's another one, okay? Someone leaving the body, okay? This is what these people believe, okay? And so the question is whether this comes from, first of all, traditional religions, whether this has any importance in science, whether any person who brings this kind of stuff, talking about energy coming out of a battery or soul or spirit or whatever you want to call it coming out of a body, you know, that dies or whatever. This is all religion. These are people who have no clue whatsoever about science. What are these people doing in science is the question. You know, they're in the wrong field. They should stick to religion on Sundays and go pray and hope that their soul goes up, not, you know, north instead of south, that sort of thing. Okay. Okay, fella says, no, we have gravity. We have no weight. Okay, and that's because I said that you don't have to weigh something in order for it to have weight. Something has weight already in outer space. You don't have to put it on a scale and weigh it. Everything in the universe already has weight with respect to everything else, even though it's in the middle of space. Okay, and so he says, no, what you have is gravity, not weight. Okay, and so, my God, we have to bring the motto again. Okay, the motto of bgaede School of Physics. What is it? We teach with a baseball bat. So I'm going to learn you. My poor God. What are these people doing in science? Okay, that's the issue. And yeah, here, let me show you. This is what this fellow, let me get myself out of here before I bash him over the head with something, okay? Yeah, weight, there's the equation for weight, okay? It's the gravitational constant, mass 1, mass 2, divided by distance squared. We have two masses, in other words, two objects, and they're separated by distance. That's all we have. That's weight. It's a static concept. Okay, there is no motion, but they say weight is a force. Okay, and I say no, weight is a tension, because it's only valid for a given location in space. And this fellow says, no, that's gravity. No, that's weight, because that's the equation of weight that you're staring at there. Do you see any requirement for a scale in that equation? Okay, it says weight is a vector quantity. Weight has magnitude and direction. And actually, weight does not need weighing. You weigh before you weigh yourself. Okay, so yeah, you already have a weight anywhere in the universe with respect to something, whether it's the Earth, whether it's the sun, whether it's Pluto, we don't care. Could be with respect to a galaxy. You're in the middle of nowhere. Okay, you already have weight because of the equation. The equation doesn't say anything about scale or about weighing. It says that if you have two masses, for example, the Earth and you, and you're separated by distance, especially from the center of that object, that celestial object, then you have weight. That's the equation. Sorry. Okay. So you got to learn the basics. Okay. Until you get a handle on the basics, maybe when you get to high school. Maybe you're still in kindergarten trying to get to first grade. I don't know. Okay. Yeah. Weight has nothing to do with weighing. Okay. Weight has to do with separation between two objects. They already have weight. You have weight. Even an astronaut in outer space has weight. And you say that's gravity. No, he's got weight according to that equation. And if you don't understand it, well, all I can do is bat you over the head or ask you politely to go into religion. Go to Sunday school. You're in the wrong field. You're in the wrong discipline. Okay, a fellow says, what happens with ropes when a new person is formed from sperm and egg? Are new ropes generated with the additional cells? My poor God, how can this be so difficult? No, we cannot create ropes. Here's a rope. Okay, this is just one rope. This is a macro world rope, right? Just in case, this is not the electromagnetic rope. The only thing they have in common is just the shape. So I use the rope as a model, as a simulation for the electromagnetic rope. But this rope cannot be made from space. And I'll give you my magic wand. Okay, it's Bill Gates' magic wand. Okay, so you got the best magic wand in the world. And you go out there and see if you can turn space into not only a rope. You want something simpler, into a cube, into a ball, whatever you want. I mean, you can't do it. You can't turn absolutely nothing, that which has no shape, into that which has shape. We're done. That's how simple it is. So no, the ropes are not created. They don't come from nothing. Okay, they've been there all along. And so that means that all matter in the universe has always been there. It was never created by God or by Big Bang, which are the two reigning theories today that almost everybody believes out there. Okay, hopefully New Year, the rope year, will change that. Okay, you said that last video that the rope was intangible. Yeah, correct. How does it bind anything if it just becomes particles without being tangible? That is what the tangle question was about. Tangle questions were about. Oh my God, let's go again. Should we learn him? How can this be so difficult? Okay. Yeah, what's the issue? The issue, there's a couple issues here. The first one is that this fellow believes that when we use the word binding and pulling, he's thinking that we're talking about two objects, the rope being a separate object from the atom. Like if, you have like they're a hook, tied to the atom. Okay, they're bound. Yeah, they're bound. And so how does something that is intangible pull on something that is tangible? That's his argument. And this is so simple. And again, this guy's in the wrong field. Should be in religion. Should not stick around in science anymore. Okay, here it is. This is the construction, okay, of the atom, which is the rope, which is the atom, which is the rope, which is the atom. Essentially, one thread goes into the center of the atom, and the other one goes around. Okay, that's how the atom is constructed according to this side. You don't have to believe it. That's the assumption. Okay, that's why it's called the rope hypothesis. In other words, we're not talking about two distinct objects. There's only one object in the universe. That's the thread, essentially. Okay, when we talk about tables and so on, we're talking about objects made out of atoms. And yeah, we have to talk about something in physics, and so we use those as objects. But if we're going to go, theoretical about it, we're going to go down to the nitty gritty, then there's only a single object in the universe, and that's the single thread. That makes up everything. Okay. And again, space cannot turn into a thread. Thread cannot turn into space, meaning the thread has always been there in the middle of nothing. meaning that which has no shape, which is space. Okay, and so what's the issue here? Well, you have, as you can see there at the bottom, okay, you have one thread makes up one part of the atom, which is the electron shell, and the other thread goes through and makes up the what we call the proton dandelion or proton star. It's like an urchin-like structure. All the threads pointed radially, okay? And so, and then on the other side, the ropes, the two threads twine again and turn into another rope. So it's not like we're talking about two objects. We're talking about a single object. So the notion of touching that you have in your mind is only between atoms. So you got to put it in the right context. Are you talking about atom touching atom, or are you talking about this system, which has nothing to do with your notion of touching? There is no touching here because it's a single thread that goes to ropes, to atoms, to ropes, to atoms. What part don't you understand? And again, maybe you need some learning. Okay, hopefully next year, we're 1 year away from 22. Hopefully next year you come to your senses. Either you come to your senses or you leave the discipline altogether. One of the two. I don't know why this is so difficult to understand. Anyways, it's too late to do questions. I'm going to take whatever you folks ask there and try to answer them next time. Meanwhile, all I can say is have a happy rope year. Okay, we'll see you next time. Bye-bye.